So this is a force table. You'll notice the force table has angles going from 0 all the way to 360, so making a complete circle. And for our first measurement, we are going to set up 100 grams at 10 degrees. So we're going to set up this marker. I'm going to have to do a little bit of adjustments on the ring, but we want to set it up so that it's right at 10 degrees. I'll put this down a second. So you can see it's at 10 degrees. I'm going to need to straighten this out on the ring a little bit. And so we have 50 degrees, or rather 50 grams on a 50 gram hanger. So that's 100 grams total mass. We'll leave that in grams for now because we haven't gotten to newtons yet in our lecture discussion. So we'll let you leave those values in grams for now. And if you notice, there's a ring in the center, and that ring is off balance. So the idea is to get this ring in balance. So we want to find the third force, and if you notice over here, we have a second hanger with 100 grams total, so a 50 gram mass plus the 50 grams of the hanger. We have set that at 135 degrees, and we're a little bit off. So let me just adjust that. So the goal is to balance this force. And so you'll see we have a third ring. So we want to find the force that balances the other two, and that's called the equilibrant vector. And the equilibrant vector is equal in magnitude in opposite direction to the resultant vector. So the first thing you want to do is pull on this until you find roughly where it's centered. So I'm pulling on this and I have the ring centered. So what I'm going to do, I've got that at about 252 degrees. So what I'm going to do is bring the third pulley over. So I know when I've got my third force at 250 degrees that if I put enough weight on it, I can get the ring to be centered. And that's what I'm going to try to do. And so the first thing to try to minimize error is see if I can get these other strings a bit more centered. And hold on one second. Okay, so I should be able to get that centered. So I have to figure out how much weight to put on. So right now, it's just the 50 grams of the hanger. So I've got an assortment of masses here. Let's try 100 grams. And as you can see, that's too much. So we want a bit less than that. So let's try 50 grams. And all right, that's already pretty good. Okay, so that's encouraging. So now we want to do the error analysis here. So we've got about 100 grams here, and I need to adjust this 1 degree still. Okay, and so the idea is first to get a d theta, or an uncertainty in theta. So we're going to see how many degrees we can turn this value, or this pulley, before we the ring winds up being off balance. So how long before the ring winds up resting on a pin? And so once it's off, and all right, so the minimum value is 247, and the maximum value is 257. So 247 to 257. So we'll center it back at 252. And keep in mind there's a little bit of friction, so that's going to introduce some error. So it's about 252 plus or minus 5 degrees. So that's your value of theta with the uncertainty. And remember that the resultant vector is going to be equal in magnitude but opposite in direction. So the angle for the resultant vector should be 180 degrees different from that, so about 72 degrees. And again, plus or minus 5 in either direction. So when you do this, the algebraic method, your force table should agree with that, the value you get with theta using the algebraic method to within 5 degrees. So now we are going to put weight on and see what, how much extra mass this can handle. So we'll set it up. We'll try 20 grams. And 20 grams pushes it off. So that's too much. So now we're finding our error in mass. So let's try 10 grams. And 10 grams pushes it off a little too much. So let's try 5. All right, 5 is not enough, so 7. Didn't notice 7. And 9. All right. Okay, so 9 appears to have been too much. So maybe 9 appears to be too much, so 7 was too little. So let's go with 8, and then let's see how much is too few. So we're going with 108 as a maximum mass. Let's see how much is a minimum mass. So we've got 70, and we've got 90, and 90 appears to be enough to get it centered. So 90 gets it centered. What about 80? Where's that 10 gram mass again? So now we're gonna try 80, and 80 is not enough. So let's try 85. 85 is not enough. But 90, once you get it pulled off, if you get it back to the center of the ring and it's not moving. So 90 and 108. So we'll take the average is 99 grams plus or minus 9. So that's the uncertainty. And keep in mind, you can see there's a little bit of friction. So you pull it and it doesn't always move. So there's some friction. So that's going to add to the uncertainty in delta M. But we have 99 plus or minus 9 grams, and we had 252 plus or minus, you'll have to go back to the recording. I think it was 7 degrees, but you can go back and double check that. And so that's the first of our measurements. So we did that with the force table. Now what we're going to do, those values are given in the book. So we'll do one more. We'll be a bit more arbitrary with this. So we'll keep this as 100, and we will put it at 20 degrees. And then we're going to make the second one 150. So we're bringing that down here. And we will set that to 150 degrees. And so now we want to find the resultant again. And again, getting the margin of error that goes with it. So again, we are pulling. We want to pull until we find an angle that looks centered. So maybe 287 degrees. So that's where we're going to set up our third pulley at 287. And let's get this as precise as possible. So 287 degrees. And okay, so we want to find what's enough weight to get this centered. So we're starting with 50. That's already not enough. Let's add 100. And 100, once again, is way too much. So let's try a 50. So 50 is not enough. So 100 grams total is not enough. So let's try a 20. So this is 120 grams. And that seems to get it just right. All right, so now we're more or less centered. So now we want to find the margin of error. So we start by adjusting the grams. So we're at 287. All right, so at 294, we get it leaning on the pin. And at 278, we're on the pin. So it was 278 to 294. So we're going to take the medium value, which is 286 degrees. So that's our medium value, but it's plus or minus 8. So delta theta is, the uncertainty in theta is 8 degrees. So 286 plus or minus 8. And so that's going to be our theta with uncertainties. And again, when you do the algebraic method, this theta should agree with the algebraic result within the uncertainty. And now we want to find the uncertainty in the mass. So we have 120. And so let's try 110. 110 does get us to push off. Yeah, so 110 does get us to push off. So 120, you can center it. 110, you can center it. Let's try 130. And that's still centered, believe it or not. So we're going to have, we have a range of at least 10 grams for this. So let's try 105. And 105 will work. But 100 did not, or at least it didn't initially. Yeah, 105 works. So let's try 130. And all right, so 130 is too much. So 105 works, but 130 appears to be too much. So 125 is not too much. So let's try 100. Where's that 2? 127. All right, that goes off. So 125 is good, but 127 is too much. So 105 was good and 125 was good. So we'll go with the central value, 115 grams plus or minus 10. And again, there's quite a bit of friction, so that's going to add to the uncertainty. But what you should see, again, is that what you're going to be doing is you're going to be calculating the resultant vector. You're going to do it using the tip-to-tail method and then using the algebraic method. So again, our base vectors are 100 grams at 20 degrees and 150 grams at 150 degrees. So you want to calculate the resultant vector using the tip-to-tail method and using the algebraic method. And you've got the uncertainty in the force table. So again, you've measured this using the force table. So it was about 115 grams at 287 degrees, but that's 115 grams plus or minus 10, and 286 degrees, plus or minus 8, I think was what we measured. And so do your force table readings agree with your tip-to-tail method and your algebraic method within the uncertainties? So that's what you're going to try to measure with this. So you have two tables to set up and to fill. And so again, you've got the force table, so you've got your values plus your uncertainties. And then you're going to do this with the tip-to-tail method using the same vectors at the same degrees. So make sure you have a protractor handy. And then using the algebraic method. So you're going to break the vectors into components. And don't forget, the equilibrant is the exact opposite direction from the resultant vector. So the equilibrant is 286 degrees. That means the resultant vector is going to be 106 degrees. So, again, plus or minus 8. So that's what you're trying to do. And if you have any questions, I'll be in the room. You can pop in and ask me. But otherwise, so that's your data for this experiment.